Today we will learn and discuss about Turing Paper. Alan Turing, Mr. Alan Turing, the picture what you are seeing, the great scientist, mathematician. Turing, as you have described here, this is Turing Digital Archive. So he is best known for helping decipher the code created by German Enigma machines in the Second World War, and for being one of the founders of computer science and artificial intelligence. So you would have seen Imitation Game, a movie. Benedict has played a Turing role. That's a brilliant movie. You should watch if you have not. Let's discuss. So 1950, Alan Turing published a seminal paper named Computing Machinery and Intelligence. So it is also known as Turing Paper. It is one of the most influential paper in computer science and artificial intelligence. And interesting part is it is also an influential work in context of philosophy of mind as well. You will get to know once. So this paper is 24 pages divided into different sections. We will briefly go through each section. Let's learn and break down this paper. So Imitation Game. So Imitation Game, you can go through this in this website. I'll quickly brief each section. So Imitation Game is the first section, as you have been reading here. It is all about Turing test. What is Turing test? It all started with, can machines think? Can machines mimic human intelligence? That is where it all started. So instead of keeping it as a philosophical phrase, Turing wants it to be proved that machines can think. So it's an attempt. So most of the part during those days and till now it is relevant. From those days to till now, those days, this first section let's talk about is all about Turing test, which is nothing but an imitation game, which is a human interrogator, or you can call it as a judge, which interacts with two entities. Let's say one with text of him, another with text of machine. So now the interrogator or a judge has to identify which one is machine. So if the machine was able to deceive the interrogator, then that is what this whole experiment or a test is all about. So if the machine can deceive, then it means that it passed Turing test. That is all this. So let me go to the second section, which is critique of the new problem. So what is this section is all about? Okay, if you see here, please write me a sonnet on the subject of the fourth bridge. Count me on this one, I never could write poetry. That's the answer. So if you see, even now this is still relevant. Even now the chatbots which we are seeing gives a sample prompt. I know it is rudimentary, this examples, but during those days itself, Turing has figured it out. So what is this section is all about? It is about why machines should feel like human. All it has to do is to give results and outcomes like human or better. Hope you are getting. So we don't want machines to be humans. So I mean, Turing's point is why machines should feel like human. All it has to do is to perform the task like human is enough. The feeling aspect, that emotion aspect, he has been ruled out with the critique of the new problem. So all it needs is intelligence. That's it. So let me go to the next section. That is all about this paper. This section, sorry, third section, machines concerned in the game. What it is. So if you go through this section, it is all about the machine is the question, is a digital computer, okay, which operates on zeros and ones. Even now, the language models at the end, when you let's say in the natural language process, in a sequence of tokens, in a sentence, if you break it as tokens, and then tokens if you give vectors, and then do the embedding, that vectorization, everything is in the binary zeros and ones. You give a unique number. Okay. So let's come back to this section. It's all about zeros and ones can be programmed to perform any computation. That is what the machines concerned in the game is all about, zeros and ones. So I'm talking this paper, just keep in mind it is 1950, which led for digital computing, electronic computers later. It's a foundation for most of the things which are relevant till today, even when I say relevant, even in the terms of innovation as well. Okay, let's go to the next section, which is, see, you would have seen in this section, store, executive unit, control. That's all a computer needs. Computer needs to store the value, execute it, and it has to respond back. An input, then a logic, then an output. Okay, so store, executive unit, control are the three parts of a digital computer. So let's talk about so we just spoke about digital computers, where it explains how digital computers work, emphasizing the ability to perform logical operations, any task that can broken down into logical steps. You got the point, right? For example, to make it short, calculator is one best example, which is a fundamental level of an example for the store, executive unit, control. So let's go to the next section, universality of digital computers. It's interesting. See, go through this in this paper. So what it is, I think, again, to summarize this, since I have read this paper, I'm just summarizing it. So if you see digital computers in the last section, which is 4, considered classified among the discrete state machines. These machines which move by sudden jumps or clicks from one quite definitive state to another. So what is universality of digital computers? This section is all about. It's about a single machine can simulate any other machine if given the right program. So let's say, which is nothing but the scalability Turing is talking about. So these are nothing but universal Turing machines. So this has come as a basis for modern computing. That's why you have in a computer's operating system, where it can do a multitasking, you can open multiple tabs, all that fundamental level theory is universality of digital computers. It is single machine can simulate any other machine if given the right program. So even the development of general purpose computer also, the foundation is this. Such a great paper. Now on the 6th section, contrary views on the main question. So here he is trying to address some common objections generally people raised when a question has arisen, can machines think? So what are those objections? There are 9 he discussed in this paper. One is theological objection. Machine cannot have souls. Second is what is that second? Heads in the sand objection. What is that? Heads in the sand objection. The idea is too unsettling. That is all it is. So we like to believe that man is in some subtle way superior to the rest of the creation. It is best if he can be shown to be necessarily superior, for then there is no danger for him losing his commanding position. I'll be quick because we are already running time. It's a 24 pages, so it takes time. Please bear with me. Third is mathematical objection. What it is? It is Gödel's incompleteness theorem limits machines. Fourth is argument from consciousness. So what is this? Machines lack subjective experience. That is what this all argument of consciousness. Argument from disabilities. Machines cannot perform certain tasks. What are those tasks? We all know. Being kind, resourceful, beautiful or friendly, sense of humor, all this where it has human capabilities, machines doesn't have. That is one of the objections. Lady Lovelace object is the sixth objection. Lady Lovelace objection, where is that? Okay, let me, here it is. Lady Lovelace, to originate whatever we know how to order it. So what it is all about? Machines can only do what they are programmed to do. But now AGI, I'm just talking about 1950 paper again. Keep that in context. Right now we have evolved from there. Anyway, seventh objection is argument from continuity in the nervous system. So human brains are continuous while machines are discrete. That's all this objection is all about. So eighth objection is the argument from informality of behavior, which tells that humans don't follow strict rules whereas machines do. That's an objection raised. Ninth objection is argument from extrasensory perception, which humans have. So extrasensory perception might confound the test. Okay. Let's go to the learning machine, 7th section. This section is all about positive nature supporting errors, return to normal objection. It's, let's say Turing argues that discrete computation can approximately continuous process to high degree of accuracy. Therefore, a back propagation, that's why there is an activate function. You know what I'm talking about right now. We knew what is back propagation, what is activate function. If not, we'll discuss in a separate section, separate video. So let's go quickly to, please go through this. So learn, adapt through algorithms, making their behavior appear informal and unpredictable. I just want to focus you this last section